All right, guys, welcome to chapter 2, section 2, limits involving infinity. I'm going to break this up into 4 small videos, and the first one basically deals with a concept of horizontal asymptotes. So what we're looking at here is we're looking at a finite limit as x goes to either plus or minus infinity. So if we look at the function f of x equals 1 over x, and we know that the graph of this looks like that, very roughly. What we see is that the limit of f of x as x goes to infinity is 0. And we also see over here that the limit of f of x as x goes to negative infinity is 0. So thinking back to algebra 2, we would say we know that there's an asymptote at y equals 0. So turns out that the official definition of a horizontal asymptote is the line y equals b is a horizontal asymptote, and I'm going to abbreviate that because I've already written it twice, of f of x if, so we got 2 possibilities here, either the limit as x goes to infinity of f of x is b, or the limit as x goes to negative infinity of f of x is equal to b. So let's do a quick example. We've got f of x equals 2 plus 1 over x. We notice that as x goes to either plus or minus infinity, f of x will go to 2 because this will go to 0. And so y equals 2 is in fact a horizontal asymptote. And we could also think about this graphically from the perspective of this is just a vertical shift. So when we shifted the whole graph of 1 over x up 2, our asymptote went to y equals 2. All right, let's look at a quick function. This is example 1. We are on page 70, and we have the function f of x equals x over the square root of x squared plus 1. If we take the limit as x goes to infinity of f of x, well, what I get is I get something infinite over something infinite. So I don't really know for sure what this is. So I'm going to go ahead and look at the graph. If I pull up the graph of this function, what I see is that it appears that this has a limit of 1. And that makes a certain amount of sense because infinity and an infinity, picking some really large number divided by itself is gonna just, they're the same number. And the 1 becomes sort of insignificant. So now let's take a look at what happens if I go to negative infinity. Well, the top is now a negative number. The bottom, because I'm dealing with the positive square root, is going to be some positive number. And this is going to have a limit of negative 1. Again, going back to the graph, what I notice is that I see that limit of negative 1. And yeah, there it is. So why don't you guys do exercise 5 in the book and then move on to the second video.